where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're drifting into one of the most quietly astonishing mysteries of existence. It's something we all live inside but can never quite hold. It guides every breath, every blink, every beat of our hearts, and yet we barely understand what it is. Time. It slips past like water through open fingers. It hurries when we wish it would linger, and lingers when we wish it would hurry. Sometimes it feels like a patient old friend, other times like an impatient stranger tapping their watch. But what exactly is time? Is it a river we float along? A ticking metronome in the sky? A cosmic illusion? Or something even stranger? Before we set sail into this quiet sea of questions, let me ask you something simple and yet impossibly profound. What time is it where you are right now? The numbers glowing softly on your clock. They feel so precise, and yet, after tonight, they may seem far more curious. If you find this little voyage soothing, if it brings even a moment of calm to your evening, I would be deeply grateful if you gave the video a like, maybe subscribed, and help this sleepy little corner of the universe find others who need a bit of gentle wonder too. So settle in, slow your thoughts, and let's begin. Because somewhere between the ticking seconds and the silent stars lies the strange, beautiful mystery of time. Have you ever noticed how slippery time feels? How it stretches, shrinks, dances, and defies any simple rule? You sit through a long meeting staring at a clock that seems to mock you with every tick, each minute feeling like a small eternity. But then, that same evening, you fall into laughter with a close friend, and hours vanish in what feels like an instant. The clock insists that both spans were measured precisely, and yet your mind disagrees. Time, at least as we live it, is not a straight road. It's more like a soft winding path through a forest, some parts familiar and quick, others tangled and slow. Sometimes it's not a path at all, but a strange dream we float through. We've all felt that odd sense of time bending during a dream. A single moment can stretch into what feels like an entire adventure, full of people, places, whole conversations, only for us to wake and realise that mere minutes passed. Or perhaps you've glanced at the clock just before falling asleep, and when you open your eyes again, morning has arrived, like a magician quietly swapping one world for another while you weren't looking. And when you're deeply immersed in something, painting, writing, reading a book you can't put down, time seems to melt away entirely. You're not watching the minutes tick, you're simply inside the moment, and the usual rhythm of time fades into the background as if politely stepping aside. But then there's boredom. Ah, boredom. The ultimate time stretcher. Waiting in a doctor's office, sitting in traffic, or listening to an explanation you've heard far too many times. In those moments, time seems to crawl, almost taunting you with its sluggish pace. Every tick of the second hand becomes strangely loud, like a drum beat echoing in an empty room. Of course, this isn't really time itself misbehaving. The seconds aren't growing longer or shorter. Instead, it's something far more personal. Perception. Our brains don't experience time in a steady stream. They stitch it together like a quilt, patching memories, emotions, attention, and expectations into what we call time passing. When you're fully engaged, your brain doesn't bother counting moments. But when you're idle, it starts noticing every little gap, filling the quiet with awareness of each tiny passing second. And then, as we age, something else happens. You may have heard people say, "The years seem to go by faster now," and oddly, they're not wrong, at least in how it feels. When we're children, the world is full of firsts. First steps, first words, first days of school. Each experience is vivid, fresh, and deeply imprinted. Our young minds are constantly gathering new information, creating rich and detailed memories. And because there's so much novelty, time feels expansive, stretched wide like the long days of summer. But as we grow older, routines settle in. The commutes, the emails, the familiar faces and places. These moments begin to blur, to repeat, to merge into one another. Our brains, efficient as they are, stop recording as many fine details. The mental scrapbook for each year grows thinner, and so, looking back, entire months can feel like they slipped past in the blink of an eye. It's not that the clock moves faster, it's that we're writing fewer pages into the book of our days. Then there are emotions, powerful amplifiers and distorters of time. Fear, for instance, has an extraordinary ability to stretch time. When you've narrowly avoided an accident or felt sudden danger, everything seems to slow down. The moments become thick, detailed, surreal. Your brain, under stress, records more information per second, creating a vivid, almost slow-motion replay in your memory. It's not that time itself slowed, it's that your perception flooded with data, making those moments stand out like heavy brushstrokes on a painting. Conversely, joy often speeds time up. A perfect afternoon at the beach, a wedding day, an evening filled with laughter. These moments fly, carried away by happiness, leaving us with a bitter-sweet feeling of where did the time go? In happiness, we live in the moment, and in doing so, we stop counting. Anticipation plays its own tricks too. When you're waiting for something wonderful, a long-awaited trip, a reunion, a holiday, time slows in the lead-up. The final week before vacation always feels curiously long. Your mind rehearses possibilities, builds expectations, and the waiting becomes its own endless event. But once the moment arrives, it often passes quickly, like sand slipping through your fingers. There's also the phenomenon of prospective versus retrospective time. In the moment, time might feel fast or slow depending on your level of engagement. But when you look back, the equation flips. An uneventful week may feel like it lasted forever while you lived it, but in memory it vanishes as a thin slice of sameness. Meanwhile, a single intense day packed with new sights, sounds and surprises might feel brief as you experience it, yet take up a large, vivid space in your memory afterwards. It's as though our minds aren't really measuring time at all, they're measuring change. The more change we perceive, the longer time seems. This is why, for many, childhood summers feel endlessly long, while adult years seem to disappear. Novelty slows time, routine speeds it up. Even our bodies have their own secret clocks ticking inside us. When you're tired, time drags. When you're energized, time flows. Jet lag, insomnia, and even hunger can bend our experience of time, as though our very biology has its own private relationship with the ticking universe. And at the far edges of human experience, in altered states of consciousness, meditation, deep prayer, certain substances or intense emotions, people sometimes report losing all sense of time entirely. Minutes, hours, even days dissolve into a timeless experience, as though stepping briefly outside the river of time and simply existing. Strangely enough, young children live quite naturally in this timeless state. Ask a 5-year-old how long 5 minutes is, and you may receive an answer ranging from forever to until I finish my snack. To them, the precise measurement of minutes and hours means little. They live inside the present moment, unbothered by the structure we adults impose, and perhaps that's part of what we lose as we grow older. That effortless immersion in the now, that childlike surrender to the simple unfolding of experience. Time, then, is not just something that happens to us. It's something we create moment by moment through perception, attention, emotion, and memory. We are not passengers on time's train. We are its co-authors. And while physics may define seconds and minutes with incredible precision, the time you actually live, the time you feel, is uniquely yours, woven from countless threads of attention and meaning. Long before physicists argued about time dilation and black holes, long before atomic clocks hummed quietly in high-security vaults, humans have stared up at the sky and wondered, what is time? It's a question as old as thought itself. For our most ancient ancestors, time wasn't a line with numbers or a ticking machine. It was the world itself. Time was sunrise and sunset, the swelling of the moon, the slow turning of seasons. It was felt in the rhythms of planting and harvest, in the migrations of animals, in the quiet hush that falls just before winter. Before clocks there were shadows, and before calendars there were stories. Imagine a campfire thousands of years ago. The stars wheel slowly overhead. The crackling flames dance, and in the soft glow, an elder begins to speak. The sun rises because the great bird carries it across the sky. The seasons change because the gods breathe warm and cold into the world, and one day the stars will fall and time will end. Time in many early cultures was a story told by nature, by gods, spirits, animals, and cosmic forces. It wasn't counted, it was lived. In ancient Egypt, time was bound to the cycles of the Nile. The river's yearly flood marked both the end of one year and the birth of another. Their calendar was built on the stars, specifically the rising of Sirius, which heralded the life-giving floods. To them, time was not just motion, it was a gift. In Mesopotamia, one of humanity's earliest cradles of civilization, time was measured with surprising precision, not with gears or quartz, but with simple observations of the heavens. They divided the day into hours and minutes based on the movements of celestial bodies. It's from them that we inherit the curious 60-minute hour, a relic of their sexagesimal base 60 counting system. Why 60? Perhaps because it divides neatly into many parts, making calculations easier for early astronomers and future generations of confused math students. Meanwhile, far to the east, ancient China also gazed upward. The Chinese concept of time blended cosmic order with earthly harmony. Cycles within cycles, the eternal dance of yin and yang. The calendar wasn't just about marking days, it was about aligning human life with the balance of nature, health, and destiny. Certain hours, days, and years were believed to carry unique energies, shaping decisions from planting crops to choosing a wedding date. The ancient Maya in Central America, however, may have built some of the most sophisticated early timekeeping systems. Their long-count calendar spanned thousands of years, mapping grand cosmic cycles with remarkable mathematical skill. To them, time was not simply linear but layered, cycles upon cycles, like celestial gears turning within gears. For the Maya, time was almost alive, not just a measurement but a sacred force to be honoured and understood. And across the vast ocean, many indigenous cultures of North America held a very different relationship with time. Time wasn't necessarily something you could lose or waste. It was circular, rooted in the rhythms of the earth. The Lakota, for example, spoke of the circle of life, a world where beginnings and endings fold into each other like the changing moon. There was no rush towards some distant future. Everything unfolded in its proper moment, like petals opening in the morning light. Even today, language reflects how differently cultures imagine time. In English, time often feels like a resource. We spend time, we save time, we waste time. Time is money. Time is a commodity, something you own, manage, and eventually run out of. But not every language treats time as such a taskmaster. In the Hopi language, spoken by some Native American peoples, time isn't described as a flowing river of past, present, and future. Instead, events are categorized as either manifest, already happened or happening now, or unmanifest, things that have not yet happened. Time, in this view, isn't a strict line, but more like a blossoming. Things unfold as they manifest, each moment gently becoming real. In Aymara, spoken in parts of South America, speakers sometimes gesture behind them when talking about the future, and point in front of them when referring to the past. Why? Because the past is known, we can see it like a landscape already walked. The future, however, remains unseen, unknowable, hiding behind us where we cannot look. It's a poetic inversion of the Western image of looking forward to the future. Even today, our expressions carry echoes of ancient beliefs. We talk of being ahead of our time or running out of time. We race against the clock or feel pressed for time. Sometimes we long to turn back time, as if it were a path we could simply retrace. And though modern life is dominated by precise measurements, alarm clocks, schedules, countdowns, many of us still live with one foot in the old intuitive world of natural time. We feel the seasons shift in our bones. We wake to the light, grow drowsy with the dark. We count the years not in numbers, but in memories. That was the summer we moved. That was the winter of the big snow. The invention of mechanical timekeeping marked one of humanity's biggest steps toward our modern relationship with time. For much of history, daily life followed the sun, the stars, the migration of animals, and the growth of crops. But as cities grew, commerce expanded, and ships crossed oceans, people needed more than sunrise and sunset. They needed coordination, to meet at the same hour, to start work at the same bell, to trade goods across continents. Early water clocks, or clepsydras, allowed people to measure time even after dark, as water dripped from one vessel to another. The steady rhythmic flow marked out passing hours. Though of course variables like temperature and evaporation kept these early devices from being truly precise. Then came sundials, which traced shadows across carved faces as the sun moved overhead. They were beautiful, elegant, but frustratingly dependent on clear skies and daytime. By the Middle Ages, mechanical clocks began to emerge. Gears and escapements driving iron hands around clock faces, bells ringing from towering steeples. For the first time, time wasn't simply observed, it was commanded. Cities could toll the hours, workers could punch in and out, and life slowly began to hum to the beat of machinery rather than the natural world. With each innovation, time grew tighter, more organised, and in some ways more stressful. The slow breathing of seasons gave way to the sharp tick of minutes. And yet, across cultures, even as technology advanced, many myths and stories still hint at time's strange duality, as both rigid and fluid, as both master and servant. In Hindu cosmology, for example, time is cyclical on a grand scale, the endless repetition of creation and destruction across vast cosmic epochs called kalpas. The god Vishnu sleeps and awakens in cycles that stretch beyond human comprehension. In this view, time itself is not a straight road, but a wheel, turning endlessly. The ancient Greeks had not one but multiple words for time: chronos, the ticking sequential time of clocks and calendars; kairos, the qualitative opportune moment when something feels right, the perfect moment to act, a kiss, a leap, a decision that blooms because the time is ripe. In our modern rush to count time in seconds and deadlines, perhaps we've forgotten how to recognize kairos, the soft wisdom of perfect timing. Time also enters our deepest rituals and beliefs around life and death. In many cultures, time is not just something you live through, it's something you return to. An endless cycle of rebirth, of seasons turning, of ancestors becoming children again. For others, time is a grand journey with a beginning and an end, a pilgrimage across a single arc, leading from birth to some eternal beyond. We mark time's passage with rites, birthdays, weddings, anniversaries, funerals. Candles are lit, bells are rung, names are spoken, each ritual a way of honouring the mysterious flow that carries us. Even our language for memory is soaked in time. We revisit old memories, we hold on to moments. We imagine the past as a place, somewhere we might walk again, if only we could find the door. And so, for thousands of years, humans have tried to understand time, not just to measure it, but to make peace with it. We have worshipped time as gods. We have told stories of immortals who step outside of time entirely. We have feared time's cruel march and longed to reverse it. And through it all, one quiet truth remains. Time feels different to every one of us. No two people experience a moment the same way. No two lives move through the same rhythm. Your time, your private, personal thread through the universe, is unlike anyone else's. And perhaps that is why, even today, with all our science and clocks and equations, time still whispers to us like a mystery. It is rhythm, it is memory, it is change. It is simply life unfolding. By now, we've floated through how time feels, how ancient cultures described it, and how it's woven into our languages and rituals. But now, let's slowly turn the lantern toward the cool, quiet halls of science, where time is not only experienced, but carefully defined, measured, and sometimes questioned altogether. What exactly is time? Even science struggles with this. Time is everywhere in science, but oddly it's rarely defined. Most theories simply assume time exists and describe how things change within it. Time becomes the silent backdrop, like the canvas on which the universe paints its patterns. But let's start simply, with what we know, or at least think we know. In our everyday lives, time feels linked to motion. The sun rises, flowers bloom, children grow. The hands of a clock spin round and round. This natural association led early scientists to define time as a way to measure change. Aristotle, the ancient Greek philosopher, called time the number of change with respect to before and after. In other words, time is the way we sequence events. Without change, time would feel meaningless. A completely frozen world would have no ticking clock, because nothing would ever happen. The idea stuck. For centuries, science treated time as a simple, steady, universal flow, like a perfectly built clock that ticks along evenly for everyone, everywhere. This view is often called absolute time, and its most famous champion was Sir Isaac Newton. Newton, with his powdered wig and Apple-related inspiration, described time as something that flows equably without relation to anything external. In Newton's world, you could imagine time as a vast invisible river, always flowing forward at the same speed, no matter where you are, no matter what you're doing. The universe's great machinery, planets orbiting, apples falling, cannonballs flying, all move according to fixed laws, unfolding smoothly within this ever-ticking cosmic clock. Drop a stone today or tomorrow, and Newton's equations could predict exactly where it would land at any given moment, because time itself was considered a constant, reliable backdrop. For everyday life, Newton's time works beautifully. When baking a cake, catching a train, or boiling tea, we still live largely in Newton's world. Seconds are seconds, and clocks march forward in harmony. But while Newton's time feels safe and familiar, it turns out the universe may not be quite so tidy. At the turn of the 20th century, something strange happened. Physicists studying light and electromagnetism discovered behaviours that didn't quite fit inside Newton's neat framework. Light, they noticed, always seemed to travel at the same speed, no matter how fast the observer was moving. This defied Newton's expectations. If you chase a car, it seems to move slower relative to you. But chase a beam of light, it still moves away at exactly the same speed. This bizarre puzzle haunted scientists, until a young patent clerk named Albert Einstein offered an extraordinary answer. In 1905, with his theory of special relativity, Einstein quietly shattered the comfortable world of absolute time. Einstein proposed that time isn't the same for everyone everywhere. Instead, it can stretch or shrink depending on how fast you're moving. This idea, known as time dilation, means that for someone travelling close to the speed of light, time actually passes slower relative to someone standing still. Imagine two twins. One boards a spaceship travelling near light speed, while the other stays home. When the traveller returns, they will have aged less than their sibling. The clocks agree, but their experiences disagree. The traveller has literally lived less time. This isn't science fiction. It's been proven experimentally using highly accurate atomic clocks placed on fast-moving planes, satellites, or even simply by comparing clocks at different speeds on Earth. The effect is tiny at human speeds, but real, measurable with today's instruments. Time, it turns out, is not absolute. It's personal. But Einstein wasn't done. In 1915, with his theory of general relativity, he went even further, revealing that gravity itself can also bend time. Einstein showed that mass and energy curve the fabric of space and time, what he called spacetime. Heavy objects like planets, stars, and black holes create dimples in this fabric, and the deeper the curve, the slower time flows near it. You're experiencing this right now. The gravitational pull of Earth slows time just slightly compared to someone floating far away in deep space. In one famous experiment, scientists placed atomic clocks at different altitudes, one at the top of a mountain, the other at sea level. The clock closer to Earth's mass ran just a little bit slower. Even the difference between your head and your feet is measurable, though the gap is so tiny that only very precise instruments could detect it. And near something massive, like a black hole, this warping of time becomes extreme. To an outside observer, someone falling toward a black hole would appear to slow down, their motion freezing in place as they approach the event horizon. But for the falling person, their own clock would tick normally. Time, in a sense, becomes profoundly local, different for each observer, depending on their position in space and gravity. Einstein's insights shattered the idea that time is a simple, steady river. Instead, it behaves like a stretchy, flexible fabric, bending, stretching, and warping in response to speed and gravity. For everyday life, these effects are tiny. But for GPS satellites orbiting the Earth, corrections for both special and general relativity are crucial. Without constant adjustments for time dilation, your phone's map would quickly become useless, placing you miles from where you actually stand. Every time you use navigation, you are quietly witnessing Einstein's flexible time in action. Even as science refines how time behaves, one haunting question remains unanswered. What actually is time? We can measure it, predict it, calculate its effects, but defining its essence remains slippery. Is time simply change itself? Is it a fundamental ingredient of the universe? Or might it be something that only exists because our minds perceive change and sequence? These questions pull us toward the edges of modern physics, where even deeper mysteries lurk. And that, dear listener, gently leads us toward the strange borderlands where time begins to blur even further, into the curious worlds of quantum mechanics, entropy, and speculative theories. But before we step too far into those swirling waters, let's pause for a moment. Take a breath and prepare for the deeper dive still to come. Because time, as science keeps showing us, is far stranger than it first appears. If relativity shattered our old ideas of steady universal time, another field quietly explained why we feel time flowing in one direction. Because here's a curious thing. Most fundamental laws of physics don't care which way time flows. If you film two particles colliding and play the footage backwards, the equations still work. Forward or backward, it all checks out. And yet, in our everyday world, time feels irreversible. You remember the past, but not the future. Eggs break, but don't unbreak. Smoke rises from a candle, but never flows back into it. Why? The answer hides in the quiet principle of entropy. Entropy, in simple terms, is a measure of disorder, how mixed up or spread out energy becomes in a system. The second law of thermodynamics tells us that in any closed system, entropy tends to increase over time. Things naturally move from order to disorder, from neatly stacked cards to shuffled decks, from structured forms to scattered fragments. It's easy to break a glass. It's nearly impossible to unbreak one. This tendency toward greater disorder gives rise to what scientists call the arrow of time, the reason we feel time moving forward. It's not that time itself pushes us ahead. It's that the universe is always sliding toward greater randomness, the low entropy past slowly unravels into the higher entropy future. Even your memories follow this rule. Memories are physical changes in your brain, traces left behind by experience. You remember the past because those traces exist. The future leaves no footprints yet. But entropy raises a troubling question. If the universe is constantly increasing disorder, then why did it start in such an ordered state? After all, for entropy to increase, it had to begin low. And yet, when scientists study the early universe, moments after the Big Bang, they find a cosmos that was remarkably smooth, simple, and low in entropy. This mystery remains one of the great puzzles of modern cosmology. Why did the universe begin so neatly organized? Why wasn't it messy from the start? Some physicists speculate that this low entropy beginning is baked into the nature of space and time itself, a kind of built-in condition of the universe's birth. Others suggest that deeper, still unknown laws may be at work, but whatever the cause, this initial cosmic tidiness may be the reason we experience time at all. Without that smooth start, the arrow of time, and perhaps our very sense of past and future, might never have emerged. And now, softly and carefully, we step into the delicate, shimmering world of quantum mechanics, where reality itself seems to blur, and time becomes even harder to pin down. In the quantum world, particles do not sit neatly in place like tiny marbles. Instead, they exist as probability waves, mathematical clouds describing where they might be and what they might do. When we measure them, the wave collapses into a definite state. But before that moment, the particle is not exactly anywhere, or perhaps it's everywhere at once. But what about time in this strange realm? Surprisingly, time plays a much quieter role in quantum mechanics than it does in relativity. In most quantum equations, time is simply a parameter, an external clock we feed into the math to track how the system evolves. Time doesn't curve, stretch, or dilate in standard quantum mechanics. It just is. A steady, silent drumbeat in the background, much like Newton's old absolute time. This creates a curious mismatch between quantum mechanics and relativity, two of our most successful theories, each describing time very differently. In relativity, time is flexible, woven together with space, curved by gravity. In quantum mechanics, time is rigid, an untouched metronome outside the system. This mismatch becomes unavoidable when scientists try to combine quantum mechanics with general relativity to create a single theory that describes the whole universe, from the smallest particles to the largest galaxies. This quest is known as quantum gravity, and it remains one of the greatest unsolved problems in physics. And here's where time nearly vanishes. In some approaches to quantum gravity, such as the Wheeler-DeWitt equation, time doesn't appear at all. The equation describes the entire universe, but has no time variable. No ticking clock, no past or future, just a vast, timeless state. To some physicists, this suggests that time may not be fundamental. Perhaps, they propose, time is an emergent property, something that arises only when large numbers of particles interact and create the complex patterns we call change. Just as temperature isn't something a single atom possesses, but appears when trillions of atoms move together, time may emerge when complexity reaches a certain level. In this view, time may not exist deep down. It only appears when observers like us experience change and memory. Some researchers even suspect that quantum entanglement, that eerie phenomenon where particles become linked across distance, might help explain time's emergence. When particles are entangled, their states remain connected, no matter how far apart they drift. And as the universe becomes more entangled over time, some theorists propose the very sense of time flowing may emerge from the growth of these connections. It's as though time is not a separate ingredient of the universe, but a shadow cast by deeper hidden relationships between particles. Still other interpretations suggest an even more fantastical possibility. the many worlds interpretation of quantum mechanics. In this view, every time a quantum event occurs, reality branches into multiple parallel timelines, one where the coin landed heads, another where it landed tails. Every possible outcome exists in some branch of reality. In many worlds, time isn't a river. It's an endlessly branching tree, a sprawling, infinite forest of alternate histories. You are living in one particular branch, experiencing one particular thread of reality. But countless other versions of you may exist, living out different choices, different moments, different futures. In this vision, time becomes less about a single flow and more about an expanding web of possibilities. And yet, despite all these dizzying ideas, we wake up every morning, brush our teeth, drink our tea, and live inside a world where time feels steady, predictable, and deeply real. Why? Perhaps it's because our human minds evolved to experience time as a sequence. Our brains string together events into narratives, into stories of cause and effect. We remember the past, imagine the future, and anchor ourselves in the present. Even if time at its deepest level is strange or illusory, our perception stitches it into a flowing river. Our lives, after all, are stories, and every story needs a beginning, middle, and end. And so, dear traveller, as we reach the edge of modern science's understanding of time, we find ourselves not with neat answers, but with an even deeper sense of wonder. Time is not simply a ticking clock. It is memory, change, possibility, and perhaps something far stranger, shimmering quietly at the very heart of reality. So far, we've wandered through feelings, cultures, and even the strange theories of physics that try to describe time. But there's another layer we've yet to fully explore. How do we actually measure time? Because while time remains mysterious in theory, humans have spent thousands of years trying to capture it, to hold it still, to count it, to build devices that mark its flow. Let's begin with perhaps the oldest and simplest tool of all, the sundial. For ancient peoples, the movement of the sun offered a reliable rhythm. A stick planted upright in the ground cast a shadow that crept slowly around as the earth turned. The sundial turned sunlight into a kind of cosmic clock face. It worked as long as the sun shone. But humans, being endlessly inventive, wanted something that worked even in the dark. Enter the water clock, or clepsydra, one of humanity's earliest mechanical timekeepers. Water would drip or flow at a steady pace from one container to another, marking off roughly equal periods. Some were surprisingly sophisticated, using gears or carefully carved basins to adjust the flow. Yet water clocks had their weaknesses. Temperature and evaporation could change their accuracy. Later came sand clocks, hourglasses, steady streams of fine grains falling through narrow glass tubes. These devices were simple, portable, and elegant, but still limited to relatively short intervals. As the centuries advanced, mechanical clocks emerged, gears, weights, and escapements turning hands around clock faces. For the first time, people could measure not just hours, but minutes and seconds, dividing time into increasingly precise slices. But even these devices drifted. A bump, a gust of wind, or the wear of metal teeth could shift the rhythm. And as society grew more interconnected, small inaccuracies became big problems, especially at sea. Sailors navigating across vast oceans desperately needed accurate time to calculate their longitude. Even a few minutes of error could mean being hundreds of miles off course. The solution arrived through sheer stubborn brilliance. The marine chronometer, perfected by John Harrison in the 18th century, kept steady time even as ships rocked on stormy seas. With it, sailors could finally chart their position with confidence, and global navigation changed forever. But science, never content to stop, kept refining its clocks. In the 20th century, a new kind of timekeeper arrived, one that didn't rely on flowing water, falling sand, or moving gears. Instead, it turned to the very heart of matter itself. Atomic clocks measure time using the natural vibrations of atoms. At the atomic scale, certain elements, like cesium or rubidium, oscillate at incredibly stable, predictable frequencies. A cesium atom, for example, ticks precisely 9,962,631,270 times per second as its electrons shift energy levels. That number isn't just trivia, it's now the official definition of a second according to the International System of Units. Atomic clocks are so stable